Welcome everybody. Welcome to our HTET Physics previous year question series. This is, I think, our sixth video in this series, and we have covered previous year for 2024, 23, 22, 21, 20, and this is for 2019. And if you have not watched our previous videos, then you can go to our channel's playlist section. There will be a playlist for regarding HTET physics previous year, so you can watch those videos. And if you find these videos helpful and useful, then do press the like button, share this video as much as possible, and subscribe to our channel. It helps us a lot. And also, some key information regarding this video, that in this series and in this video also, we are only going to cover questions of 11th and 12th class only, because most of the people which are sitting in these exams are working professionals and school teachers, and they are only means they are on day-to-day basis in their classes in the school. They are dealing with 11th and 12th syllabus only. So if we solve here some MSc or BSc questions, then they will not be as much as relevant for them as 11th, 12th question, because from that they get the basic idea that how much questions they can easily attempt in a during the exam. So with this, let's start today's video, and hopefully you will find it useful. So starting with here question 91, and yes, one more thing, here we have a QR code. If you like to support us financially, then you can scan this QR code and donate us with whatever amount you want. Now with this, back to the question. In a certain mass spectrograph, an ion beam passes through a velocity selector consisting of a mutually perpendicular electric and magnetic field E and P. The beam then enters into the region of another magnetic field B dash perpendicular to the beam, the radius of the curved path followed by the beam. So we know that when a beam is passing through a velocity selector, then that velocity that is getting selected is given by V is equal to E by B. Now this beam or this ion beam has this velocity, and when there is a charged particle with certain velocity, it enters into a magnetic field which is perpendicular to its velocity. Then it moves in a curved path with whose radius is given by mv by q into magnetic field. Here magnetic field for the curved path will be b dash, so r is equal to mv by qb dash. Now value of v is e by b, so this will become me divided by qbb dash, and from that we can write that r is proportional to e divided by pb dash. That is option 4 for us. So option 4 is going to the right answer. Now coming to the next one. Consider a nucleus of mass m consisting equal number of proton and neutron. If the radius of the nucleus is 3 by 2 times smaller than the 27 aluminium nucleus, let me increase it slightly, then the binding energy of this nucleus is. So basically we have to find out the mass number of the nucleus. Now regarding the radius, we have a relation. We know that radius with n number of we can say radius with z atomic mass is equal to r naught times z raised to power 1 by 3. Now suppose the atomic number the mass number for the nucleus in question is z, so we can write that its radius will be r naught times z raised to power 1 by 3, and this is 3 by 2 times smaller than those that of aluminium. So for aluminium it will be r naught times atomic mass is 27 given for aluminium raised to power 1 by 3 divided by 3 by 2. So r naught is cancelled. Now this will give us 3. So z raised to power 1 by 3 will be equal to 2, and from this z is equal to 8. So atomic mass which we are dealing with here is equal to 8. Now as mentioned here, it has equal number of proton and neutron, so we can say there will be 4 protons and 4 neutrons. So here uh, we have to find out binding energy. So binding energy will be equal to the mass difference. So that will be equal to EB will be equal to 4 of mass of proton plus 4 times mass of neutron minus Mn, where Mn is the mass of the nucleus, times C square. This is the mass difference. And if I compare it, then we have only option 1 that matches with it. So option 1 is the right answer. Now in the next one, an arrow is shot horizontally with a speed of 20 meter per second from a top of a tower 60-meter high. The time to reach the ground will be. So we have been given horizontal velocity, and we know that horizontal velocity does not affect the time required to reach at the ground. And we can directly calculate the time. So time will be equal to under root twice of h by g. Now here height is 60, so twice 60 by g is 10, so that will be basically under root 12, and that can be written as 2 root 3. Now root 3 is 1.73, so 2 into 1.73, that will be 3.46 second. That is option second here. Now moving to the 94th. Two planets have the same mass m. Each planet has a constant density, but density of planet 2 is twice as high as the one of the first. Identical object of mass m are placed on the surfaces of the planet. What is the relationship between the gravitational potential energy U1 and U2 between the planets? So we know that formula for gravitational potential energy U is equal to minus G capital M small m divided by the distance. Now capital M is the mass of planet here and small m is the mass of body here. So as per mentioned, both have the same mass. So we can say M1 is equal to M2. Now we have the density relation, and if both have the same mass, means there will be difference in the radius. Their radius will be difference. And in terms of mass, we can write mass is equal to density times volume. So this will be rho 1 V1 is equal to rho 2 V2. Now suppose rho 1 is rho, and V1 will be 4 by 3 pi R1 cube, and rho 2 is twice of that of first, so that will be twice of 2 rho, and again volume is 4 by 3 pi into R2 cube. Now 4 by 3 cancel from both sides, and rho is also cancelled. From this we will get relation between R1 and R2, that R1 cube is equal to 2R2 cube, and from that we can write that R1 cube by R2 cube is basically equal to 2. Now if we write U1, then U1 will be minus G M, because capital M is same, where small m is the mass of body, and we are taking same body on both of the we can say planets. So small m will also stay the same, divided by R1, and U2 will be minus G capital M small m divided by R2. From this, what we will have? We will have U1 by U2 is equal to R2 by R1. And from this, we can write that R2 by R1 is equal to 1 by 2 power 1 by 3, or basically cube root of half. So from this further, we can write that U1 by U2 is equal to 1 by 2 and cube root of 1 by 2. Now we know if we had under root of 2, that would be 1.41. So this will be 1 by 1.41. So the term will be, or if we write the relation, then it will be U1 is equal to U2 divided by 2 raised to power 1 by 3. Now we directly don't know the value of cube root of 2, but we are sure that if we take cube of 1, then it is 1. So this value will be greater than 1, and if we our denominator is greater than 1, then this whole value will be smaller than 1. So our answer will be something like 0.xxx of u2, where these three will be some numbers, And if we match, then only this answer, this option 4 is going to match with our result. Now let's move to next one, 95th. So for a varying current I1 cos omega t plus I2 sin omega t, the RMS value we have to find out. Now regarding RMS value, we have a relation that suppose we have to calculate value RMS value of some current, then it is given by integral I square dt divided by integral dt raised to power whole raised to power half. That is the basic method. It involves integration, and we have another method also, that IRMS is equal to under root of I square average value. This is basically average value of I square, and we can also use this method. Why? And I will be using this method here, that I will be finding average value of I square. Why? Because regarding average, we know some average values, because here sine and cos theta sine theta and cos theta are involved. So we know that their average value is 0. So that's why I will not go into the integrals, because it will be lengthy. I will be directly using average power or average values. So let's find out first of all I square. So I square will be I1 square cos square omega t plus I2 square sine square omega t plus, that will be twice of I1 I2 sine omega t cos omega t, and this can be written as I1 square cos square omega t plus I2 square sine square omega t plus I1 I2 sine of 2 omega t. Now if I find the average value, I square average, then it will be I square, I1 square will stay as it is because it is a constant value. Then average value of cos square omega t will be half. So this will become I1 square by 2. Similarly, average value of sine square omega t is also half. So this will be I2 square by 2. And average value of sine theta or cos theta is always 0. So the average value of I square will be I1 square plus I2 square by 2. Now this can be written as I1 square plus I2 square divided by 2. Now I can take under root of this. So IRMS will be equal to 1 by root 2 I1 square plus I2 square raised to power half. And that is basically option 3 for us. So option 3 is going to be the right answer for this one. Now let us move to the next one, 96. The magnetic field B node is applied to a paramagnetic substance. In the interior of the magnetic substance, the magnetic field produced by atomic magnet dipoles of the substance. So here substance is a paramagnetic substance, and we know that paramagnetic paramagnets are weakly attracted. So they are weakly attracted. So what does it means? That inside them the net field will be smaller. So suppose this is a paramagnetic substance. If it is strongly attracted, then its inside field will be greater. And if this material is weakly attracted, then inside field is always going to be smaller, because the induced field is in the opposite direction. That's why the net resultant field is in the same direction, but in the amount gets reduced, the magnitude gets reduced. So here we can say uh, less than the applied field, but in the same direction. And here keep in mind that induced field is in the opposite direction, but net field is in the same direction. So option 4 will be the right answer here. Now if same question comes with ferro, then this will be in the same direction, and we can say greater than the applied field. And for this, if it comes with diamagnetic, then it will be in the opposite direction and weak, because it is repelled. So with this, let's move to the next one. The peak to peak value of amplitude modulated wave has a maximum value 8 volt and a minimum value is 2 volt. The amplitude of unmodulated carrier is. So here we know that maximum value of the modulated wave, that is Vmax, it is always equal to the carrier waves plus the signal wave, and minimum value of the modulated wave is equal to carrier wave minus the signal wave. So here maximum value is 8 and minimum value is 2. Now if we add both these two, we will get twice of AC is equal to 10. And from this, carrier wave has an amplitude of, we can say, 5 volt. And that is option 4 here. Now in the next one, two short electric dipoles are its separation r from their dipole moments along the line joining two dipoles. The force interaction F between the two dipoles varies as. So both of dipoles are along their axis because they are placed in such a way that there is a line joining their dipoles. So suppose this is first dipole, so and its dipole moment is along positive x direction. Then second dipole has to be this, or we can say in the opposite direction. So basically both of these are along axis, and we know that along axis electric field by dipole is equal to P by 4 pi epsilon naught RQ, where R is the distance from the charge particle. Now, for a dipole, the force experienced by a dipole is equal to P times dE by dr, where r is the distance. Means if electric field is changing with distance, only then a dipole experiences a force. So from this we can write that force will be equal to force on the second dipole due to the first dipole will be F2 is equal to P2 into dE1 by dr, where dE1 is the electric field here produced by the first dipole. This is first dipole, this is second dipole. We are calculating force on the second dipole due to the electric field of the first dipole. So we will take electric field of the first dipole. So this will become P2 into this will be E1. So it will become P1 by 4 pi epsilon naught into derivative of d by dr of 1 by r cube. So this will result in that force will become proportional to 1 by raised power R4. And that is third option here. So third option with the right answer. Moving to the next one. The wavefront of a light beam is given by equation x plus 2y plus 3z is equal to c, where c is an arbitrary constant. Then the angle made by the direction of light with the y-axis is. So I think we have covered this type of question in our one of previous video, that if we have been given an equation for a plane, here this is x plus 2y plus 3z equal to c, then light will strike perpendicular to it with some direction. It will either strike perpendicular to x or y or z. So what we have to do, we have to find out normal vector, and normal vector will be here equal to I. We just have to take the magnitudes of each direction, I plus 2j plus 3k. This will be the direction of the normal vector to it. Now here light is striking perpendicular to the y direction. So we along the y direction. So we have to find out angle with the y direction. So suppose this is our normal vector and this is our y-axis. So we have to find out this angle theta. And how we can calculate? We can use the dot product, that y dot n will be equal to modulus of y, modulus of n, and cos theta. Now y vector is basically, it is equal to j. So it will be, if we take j dot this, then we will get 2. And from this, magnitude of j is 1 and magnitude of this n will be 9 plus 4 plus 1, that is under 14 into cos of theta. So from this, cos theta is 2 by root of 14 and theta will be cos inverse 2 by root 14. That is option third here. Now let us move to the 100th question. Light wave of wavelength 6500 angstrom passed through a slit of width zero point 0.1 centimeter to produce diffraction pattern on the screen of distance 1.8 meter from the slit. If the entire apparatus is immersed in water, then width of center maximum. Now we know that width of the center maximum in case of diffraction pattern is equal to 2 lambda d by a, where a small a is the slit width. Now, when we immerse this whole apparatus into the liquid, then wavelength will change. It will become lambda dash, and lambda dash will be equal to lambda by mu. So we can say omega dash will be equal to twice lambda d by mu times a. So this will be twice. Lambda is original is 6500 10 to the power minus 10, where d is 1.8, and mu is 4 by 3, so 4 into 3, and a slit width is zero point 0.1 centimeter, or 1 into 10 to the power minus 3. So now what we can do, we can basically cut it by half, and this will be 0.9. So basically I will have 2.7 into 65000 into 10 raised to power minus 7, and this will on calculation will give us 17550 into 10 raised to power minus 7, and this will give us 1.75 into 10 raised to power minus 3 meter, or this is basically 1.75 mm. That is second option here. So second option is the right answer for this one. So let's move to the next one. 101. An unpolarized beam of light has intensity I node. It is incident on a system of two identical polaroids. The angle between the polarization of these polaroids is theta. If emerging light has intensity I node by 4, then we have to find out value of that angle theta. So suppose we have two polarizers. Suppose this is our first polarizer and this is our second polarizer. Now, for the first polarizer, this is first, this is second. For the first polarizer, what we will have, we have light of intensity I nodes incidenting on it, and we know that if we have unpolarized light incidenting on, we can say some on one polarizer at any angle, then output will be always I node by 2. Now, suppose with respect to first polarizer, second polarizer makes angle theta, then output of second polarizer will be I node by 2. This is the incident light into cos square of theta, and this is given to be equal to I node by 4. So this is equal to I node by 4, and from this we can find out that cos of theta is 1 by root 2, and that matches with option 4 here. Now with this, let's move to the next one. 102. So here we have, let me write increase thickness. So here we have a rod of length L rotates with uniform angular velocity omega about its length perpendicular about its perpendicular bisect. A uniform magnetic field B exists parallel to the axis of rotation. The potential difference between the two ends of the rod will be. Now here it is asked that we have to find out potential difference between the two ends of the rod, and we don't know that what is the point of rotation. Means suppose if I have this rod, then I can rotate it about center, that is suppose point O, and I can also rotate it about one end, that is suppose point A. Now if I am rotating it about center, if it is rotating about center, then both of these endpoints, suppose this is A and this is endpoint B, then both of these center will be at the same potential and their potential difference will be 0. So according to that, our answer will be 0. But if I am rotating it with about point A, then we can find out the value of induced EMF due to motion of the charge carrying conductor in a magnetic field. There will be a induced EMF. So for that, suppose this is our conductor rotating about point A. Now we take small element of length dx about x, distance x from the point A. Then induced EMF in this small element dx will be equal to BLV, where B is the magnetic field L is the length of this small element, that is dx here, into velocity of this small element. Now as it is rotating with angular velocity omega, so this velocity will be omega times x, so this will become b omega x dx. And if we integrate dE, then we will get p omega x dx integral from limits 0 to L, and if we solve this we will get half b omega L square. So from that perspective, we will get answer as second. And in the given answer, that is option 2. But we can say statement is not certainly clear here that whether it we can lead to both answer option 1 and option 2. So it's up to the examiner, or this kind of questions can be raised with some doubts. So be cautious. But this is the general form and this is a specific form, but both can be possible here as it is not clear in the question. So let us move ahead. Now that is 103, I think. Yes, 103. A small ball is suspended over an infinite horizontal conducting plane by means of an insulating elastic thread of stiffness K. As soon as the ball was charged, it descends by distance x, and separation from the conducting plane becomes equal to L, the charge given to the ball. So this is question basically from the we can say electrodynamics, and we can skip it. But just to give you an idea that this is a conducting plane question, so this involves mirror charge. So here we have plus q charge at distance L. Then there will be a negative induced charge at same distance L. So both of these attract each other. So from that we can write that force of attraction between them will be equal to 1 by 4 pi epsilon naught q square by 2L square. Now this force will stretch this the thread to which this charge is attached. The upper charge, this charge is attached to a thread with the help from attached, we can say, what is happening here? Yes, it is attached to a thread. So due to this force, there will be extension in that thread, and that extension can be written as like spring, that is K times X, and that will become equal to this 1 by 4 pi epsilon naught Q square by 4L square. And from that we can calculate the value of Q. But we are going to assume that we are going to skip this question. Now moving ahead to the question 104. A straight conducting wire of uniform cross section carries a current I, let S be the specific charge on an electron. The momentum of all free electrons per unit length of the wire due to drift speed only is. So we have to find out uh, momentum per unit length of all the free electrons. So, and here it is mentioned that S is equal to E by M, that is charge to mass ratio. Now we know that momentum is equal to mass times velocity, and for electrons in the wire we will have drift velocity, so momentum will be M times Vd. For current we know that I is equal to NEA Vd. From this drift velocity comes out to be I by NEA. Now, if we convert it into momentum, then mvd will be equal to mi by nea. This is the momentum. Now we have to find our momentum of all free electrons per unit length. So we have to first, let's make it per unit length. So divided by L. So here we will have L, and we have to find out for all free electrons. So let us multiply it by capital N, where capital N is the number of free electrons. So here we will also have capital N. So this is the term we have to calculate, and this is equal to this number. So we will let's say we will solve it further or modify it slightly using the given values. So first of all, this E by M will be equal to S here. So this will become I by S into A this small n is the number density, so it will be equal to total number by the volume or capital V, and volume is again equal to area times length. So we write it as AL, and we have L here and we have N here. So this N gets cancelled, L gets cancelled, and A gets cancelled. So basically we are left with only I by S, and that is the option. That is second option and the answer required here. So with this, let's start move to next one. 105. A drop of oil of density rho is floating half submerged in another liquid water of density rho. The surface tension is d, the radius of the drop we have to find out. So suppose this is our container, and here we have a liquid. This is some liquid of, we can say, density rho. Uh, oh sorry, density of liquid is going to be sigma. So this liquid has a density sigma, and we have a drop, oil drop, that is half submerged. So half is outside and half is inside, and its density is sigma. So we know from the fluid mechanics that there will be a buoyant force on it, and as surface tension is also mentioned, so there will be also a upward surface tension on it. And how that surface tension will look, if I draw a 3D map, I think it will be fine. So suppose this is our drop, and it is half immersed in the water. So along the circumference of this drop, along this green path and this green dotted path, there will be surface tension, and that surface tension will be acting in the upward direction. So there will be a force due to surface tension along the circumference in the upward direction. There will another force in the upward direction, that is buoyant force, and the mass will be acting for this ball in the downward direction. So our balancing equation will be that force due to surface tension. We know that for surface tension, surface tension is basically force per unit length. So force due to surface tension by length, it is acting along the circumference, so length will be 2 pi times radius, is equal to this given value of surface tension, that is t. So f of s is equal to 2 pi rt, and balancing equation here will be that f of s plus f of b, where fb is the point force, is equal to mg. So f of s is equal to 2 pi rt. Buoyant force will be v by 2, as half volume is inside the water, into density of water, that is sigma, into gravity, and is equal to mg, or that can be written as v rho g. Now from this we can write that T times 2 pi r is equal to Vg into rho minus sigma by 2. And now what we can do, we can substitute the value of volume. So this will be T 2 pi r 4 by 3 pi r cube G rho minus sigma by 2. Now this r gets cancelled in the square, pi gets cancelled, 2 gets cancelled, and from that we can write that r, I think, yes, r is equal to under root of 3t divided by 2 rho minus sigma into g. And here it is, I think, 3t g 2 rho minus sigma. That is option, second option here. Now let's move to next question, 106. So in a sample of hydrogen gas atom are in the ground state, on this sample monochromatic radiation of wavelength lambda is incident. By partial absorption of this radiation, atom reached in the excited state. These excited atoms emit light containing 6 spectral lines. The value of wavelength is about. So first of all, there is a mistake in the question, that as mentioned, that there is a partial absorption and then there is excitation. So if we have partial absorption of some radiation, then it has to be an ionization, because for excitation there has to be a complete absorption. That is the basic law of quantization, that if there is excitation is happening, that light, that wavelength of light, oh sorry, that photon of light, or that given light radiation has to be completely absorbed. Only then electron jump from one orbit to the another. And if there is very high energy, then there will be partial absorption, but for that partial absorption ionization is necessary. That atoms goes into an ionized state, and that electron, ejected electrons, will come free, and it has some kinetic energy, and that how we can have conservation of energy. So basically, there cannot be partial absorption, there has to be complete absorption. Now coming to the number of lines, as we have 6 number of lines, so for hydrogen spectra the number of lines are given by n into n minus 1 by 2, and this is given equal to 6. So we know that in this equation, if we substitute n is equal to 4, we will get 6. So n is equal to 4 here. And now if n is equal to 4, means initially our electron was in the ground state or in the first state, and then it moved to fourth state. So for hydrogen atom, we know En is equal to minus 13.6 by n square electron volt. So energy of the first orbit is minus 13.6 electron volt, and energy of the fourth orbit using this formula will come out to be negative 0.85 electron volt. So delta E, the energy difference required for the energy required for this transition will be, we can say, E4 minus E1, that will give us 12.75 electron volt. Now from this we can calculate the, we can say, radiation, wavelength of the radiation. We know that lambda is equal to hc by E, because E is hc by lambda, and hc is equal to 1240 electron volt nanometer, and divided by energy, that is 12.75 electron volt. So electron volt get cancelled, and if we divide this, then what we will get, we will get something around 1000, because this, if we assume this is 12.4, then this will give us 1000, something around 100 nanometer. So I'm just approximating it. So it will be approximately equal to 100 nanometer, and that will be approximately equal to 1000 angstrom. And that nearest answer is that to us, that is 973 angstrom, and that is also the right answer. So let's move ahead to the next one. And this is question number 107. So which of the following process must violate first law of thermodynamics? Now first law of thermodynamics, we have delta Q is equal to delta U plus delta W. Now moving with the first one, it is given that W is greater than 0, so this term is positive, and Q is negative, so this term is negative. So it means this delta U has to be negative, and it is given equal to 0. So first one is wrong here. So first one must be in the answers, and that is given in all 4 options. Now moving to the next one, that again work is 0, Q is 0, and here delta U is given to be positive. So again that should also be wrong, because from this delta U has to be negative, only then their sum will be negative. So it has to be negative. So second should also be in the given options, and that is not given in the first one, not given in the second, not given in the third, only given in the fourth. So from this we can conclude that option 4 will be the right answer here. Next move to the next one. 108. A train approaching a railway crossing with a speed of 1000 by 3 meter per second sound a short whistle 640 hertz when it is 300 meter away from the crossing. The frequency heard by the person standing on the road perpendicular to the track through a crossing at a distance of 400 meter from the crossing will be. So as we know that this is a question related to Doppler effect, and in case of Doppler effect, it does not matter what is the distance. The only thing that matter is the apparent speed or relative speeds. So for Doppler effect, we have formula that F dash apparent will be F node original times V plus minus VO by V plus minus VS, where VO is the speed of the observer, VS speed of the source, and V is the speed of sound. So here we will get original frequency is 640, and here train is approaching, means we can say our source is moving, not the observer. So upper this V of O will be 0. So here we will get 340, that is the speed of sound, divided by 340. And as train is coming near, so it will be subtracted. So 100 minus 3. And when we solve this, what we will get? We will get, let's solve this basically. So 640 into 340 into 3 divided by 340 into 3, that is 1020 minus 100, that is 920. So this 0 gets cancelled, and this will be 132, this will be 146, this will be on 16, this will be on 23. Now what we can do, we can approximate. So 16 into 340 into 3, let us write this 23 as 24. So then it can we can cancel it by 8. So this will be 2, this will be 3, this will get cancelled, and this will give us 680. And that is the exact answer we have. So if we are just using approximation, why? Because we have to save some time for the exam, during the exam. So with this, let's move to the next one, 109. The So here in the 109 question number, the inductance of a solenoid is 50 millihenry and resistance is 0.025 ohm. If it is connected to a battery, then how much time the value of current in it will become 50% of the maximum value. So for charging of inductor, we know that it is the current equation is given by I is equal to I node 1 minus E raised to power minus of t by tau, where tau is the time constant. Now it is given that current reaches 50% of the maximum value, so it basically becomes I node by 2, then it is equal to I node 1 minus E minus t by tau. Cancelling this and solving this, we will get E raised to power minus t by tau is equal to basically half, and if we take say ln of both of these sides, from that we will get t by tau is equal to ln of 2, and ln of 2 is 0.693. That is the standard value, we have to remember it. So time is equal to t. Tau, that will be L by R. So L is 50 millihenry, so 50 into 10 to the power minus 3 by R, that is 25 into 10 to the power minus 3 into 0.693, that is ln 2. And when we solve this, we will get 1.386 seconds. That is 1.39. So with this, let's move to the next one, question 110. So on connecting a 20 picofarad capacitor by a battery, it attains a potential of 50 volt in the time interval of 0.5 seconds. The plate area of capacitor is given at the instant the rate of change of electric field. So rate of change of electric field we have to find out, and we know that electric field is given by E is equal to V by D. And if we have to find rate of change, then we can write that it is will be dE by dt. So this will become basically 1 by D as it is into dV by dt. Now how to calculate dV by dt? That is basically given in the question, that plate attains 50 volt in time interval of 0.5 seconds. So this is the dV and this is the dt. Means I can write it like 1 by d delta V by delta t. So delta V and delta t, both of you are given to us. Then we have to calculate 1 by d, and that can be calculated from this, that C is equal to epsilon node A by d, and from this 1 by d is equal to or let's calculate t basically. D is epsilon node A by C. Now epsilon is 8.85 10 raised to power minus 12 into area that is given to be 5 into 10 raised to power minus 2 divided by C that is 20 pico, so 20 into 10 raised to power minus 12. And from this we will get 2.25 into 10 raised to power minus 2, that is T. And now we can calculate dE by dt, and that will be equal to 50, that is delta V, small d, that is 2.25 10 raised to power minus 2 divided by 0.5, that is time. And from this we will get 4.5 into 10 raised to power 3. And from that, none of the given answer is matching, or we can say nearest answer is option 1, but none option matches exactly. So with this, let's move to the next one, 11111. An electrical engineer requires a capacitance of 2 microfarad between the circuits across a potential difference of 1000 volt. A large number of 1 microfarad capacitors are available to him, each of which can withstand a 400 volt. Now, as each capacitor can only withstand up to 400 volt, and we need capacity up to 1000 volt, so what we need to do, that we have to arrange them in series basically. So this will be a first capacitor, this will be second capacitor, and this will be third capacitor. This will drop 400 volt, this will drop 400 volt, and this can drop 400 volts. So combined they can drop total 1200 volts, and that is more than the required, because if we add only 2, then that will be 800, and that is less than the required. So we have to add at least 3 capacitor in series to get this desired potential difference capacity, that is 1000 volt. Now each of these capacitor is of 1 microfarad, so 1 microfarad and 1 microfarad. Now when these all three are in parallel, so their combined capacitance will be 1 by 3 microfarad. Now if we add such n systems in parallel, then their capacitance will be added, so that will become n times 1 by 3, and it has to be equal to 2. So from this we will get n is equal to 6. So we have to place 6 such system in parallel, and in each system there is 3 capacitors, so total number of capacitors required are 6 into 3, that is 80. Now let's move to the next question, that is 112. A radioactive nucleus X decay constant lambda X transform into another radioactive nucleus Y with decay constant lambda Y. Initially, the sample contains nuclei X only with population NX. Note the population of Y as a function of time. So this question is basically related to MSc nuclear physics concept. So we are going to skip here this type of question. Now with this, let's start move to next one, 113. So here we have a negative test charge is moving near a long state conductor carrying current. The force will act on the test charge in a direction parallel to the direction of the current if motion of the test charge is. So we have to find out direction of motion of test charge. So let us assume that we have a wire, and our wire is we can say is in the z direction. So it will be represented as dot here, because wire is coming out of the plane of this screen. So current in this wire can be either into the plane or out of the plane. So we can say direction of current, or I, can be plus K or minus K. Now what will happen due to this direction? Using we can say right hand screw rule, we can find out direction of magnetic field. So if for the positive K, that is the current coming out of the screen, magnetic field will be something like this. It will be in the clockwise direction at this point. And for minus K, magnetic field will be like anti-clockwise in this direction. So we are only discussing regarding positive X direction. Now coming to the that force on the test charge is direction parallel to the direction of current. So here in this case force is in the positive K direction, and in this case force is in the negative K direction. And we know that force on a charged particle is equal to That is the only direction. So according to formula, force is equal to Q V cross P. So if we write only direction, then in this case, direction is positive K. Charge does not have any direction, but this is a negative charge. So here we will have negative E. Now coming to the velocity we have to find out. So velocity is as it is. Magnetic field at this point is in the positive J direction. It is going upward, so it will be V cross J. And from this we can write that direction of velocity will be minus I, means charge will be coming towards the conductor in this case. And for this case, we have force in negative K direction, we have negative charge, velocity as it is, and magnetic field is in the downward, means minus of J direction. And if we solve this again, we will find out that charge will be moving in the minus I direction. Why? Because this minus minus gets cancelled, and we have the same formula as the previous one. So in both of the cases, charge is coming towards the conductor. So that will be the right answer. That option 1 is the right answer here. Now let us move to the next one, 114. For a diamond, the permittivity is given by this relation, its electric susceptibility we have to find out. So likewise for magnetics, we have a relation that Xi is equal to mu r minus 1, where mu r is the relative magnetic permeability. So similarly for electric, we have psi e is equal to epsilon r minus 1. So that will be equal to psi e. Epsilon r will be epsilon by epsilon naught minus 1. And from this, psi of e will be equal to 1.416 10 to the power minus 10 divided by 8.85 10 to the power minus 12 and minus 1. And this will give us 16 minus 1, that will be approximately 15. That is second option 2. Moving to the next one, the expectation value of x in the one dimensional simple harmonic oscillator. So that is basically related to quantum mechanics, and we are going to skip it here. The next one is related to diode, and we have to find out diode current. So here we have to use diode equation. We know that diode, uh, actually we are going to skip it because this diode equation is not covered in the 11th, 12th. But for diode equation, we have I is equal to I node e raised to power, I think it is neta vt or some divided by k some minus 1. It is something like this, and that can be easily solved if you know the diode equation properly. So we are going to skip it. Now in the next one, the magnetic vector potential associated with some magnetic field. Again, this is related to PSC MSC, so again we are going to skip it. Now moving to the 118. A clock on the wall has a marks instead of number on its dial. On the opposite wall, there is a mirror, and the image of the clock in the mirror is red. It indicates 8:20. What is the time in the clock? So actually what we have did here, that we have read time in the mirror. So let me first draw the mirror here. If I have the 12 direction, yes, I think it will work. So suppose these are the actual time. So this is 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the actual time. And if we see this in the mirror, then what will happen? Then time in the left will go to the right, and symbols on the right will go to the left. So this one will be here. So I can say this is time we can which will be visible in the mirror. 1, 2, 3, 4, 5, 6 will stay as it is. 7, 8, 9, 10, 11, 12. So as per the mirror, we have read 820. So as per the mirror, we have read 820 means uh, one of the dial will be here, the minute dial will be here because only 4 indicates 20, and 820 means uh, dial will be something greater than 4. It will be something high, sorry, it has to be higher than, as it is 820, so it will be between 8 and 9 hour dial, so it will be something like here. Now if we see it properly in the non-inverted or in the actual, so it will be between 3 and 4, so it will be 3, and at 8 we have 40 minutes, so this will be, we can say, 340 in actual, and that is option 1. And if you don't want to do it like this, then we can say there is another direct formula, that actual time plus mirror time will add up to 1160, 11 hours and 60 minutes. Now here minute time is 8 hours and 20 minutes, so actual time will be 1160 minus 820, this will give us 340. That is the required answer. So you can solve it either this way or this way, both are right. So moving to the next one. Three coherent equal intensity light rays arrive at a point P on the screen to produce an interference minima of zero intensity. If any two of these rays are blocked and resultant intensity at light is I1, the only one ray is blocked, then the resultant intensity at P will be. So as mentioned that we have three coherent sources of equal intensity. So I1 is equal to I2 is equal to I3, and that will be equal to some standard intensity, let us say I0. Now when they interfere, they produces minima. So we can say I1 plus I2 plus I3 is equal to 0. The resultant intensity is 0. But if two rays, or we can say if any one ray is blocked, means two rays combine with each other. So I1 plus I2, the intensity is I1, and I1 is equal to I0. So basically we can say I1 plus I2 is equal to I0. Now if I substitute this expression here, then what I can write, that I0 plus I3 is equal to 0, and I3 is equal to minus of I0. Means third ray is basically cancelling the effect of these two rays. Now coming to the question, that only if one of the ray is blocked. Now if one of the ray is blocked, means either we have I1 plus I3. Oh, sorry, a correction here. I misread the statement. That this part I got it wrong. Let me correct it. Now statement was that, let me fix this one first. Statement was that if any of the two rays are blocked, if any of the two rays are blocked, means only one ray is coming, and then intensity is I1. So we can say either I1 is coming, or I2 is coming, or I3 is coming, and its intensity will be basically equal to I0. Now from this formula, what we can write, that suppose I1 is coming and we have blocked I2 and I3. So from this we can write that I1 is equal to I2 plus I3 negative, and I1 is equal to I0. So that I0 is equal to negative of I2 plus I3. Now as per the question, that if only one ray is blocked, means two rays are allowed, and if two rays are allowed, their combined intensity is equal to I0, which is equal to either I1, I2 or I3. So we have to find the resultant, and that resultant will be basically again equal to I1, because intensity is not zero, we are only getting it mathematically equal to mathematically negative. So option 2 will be the right answer here. Now moving to the next one. 120. The Boolean expression P plus P bar Q, where P and Q are the inputs to the circuit, represent the following circuit logic gate. So here we have P plus P bar Q. What we can do here, we can make a truth table for regarding this. So let me add a table. I think we have a table option here, but we need 3 to 5, and yeah, this will work, I think. So this will represent P, this will represent Q. This is P bar, this is P bar Q, and this is resultant. That is equal to, okay, I think there is some problem. Yeah, that is Y, and that is P plus P bar Q. So that will be 0, 0, 1, 1, 0, 1, 0, 1. These are the maximum possible combination. Now P bar will be 1, 1, 0, 0. Now P bar into Q, that will be 0, 1, 0, 0. And if we add these two, this will be 1 or 1. Oh, sorry. We have to add P plus P bar Q. So these two has to get it. So 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. And this is last 1. And this is a table of OR gate. This result matches with the OR gate. So answer will be option 4, that is OR gate. Moving ahead, 121. A scalar potential field is given by this relation volt, the magnitude of the force on the 4 coulomb charge particle. So we are going to skip it because we have a scalar field here, potential field here. Now in the next one, the amplitude of an oscillator having frequency 300 seconds per oscillation reduces to 1 by 10th of the initial value after 6000 oscillations, the damping constant. So this is again damped harmonic oscillator, so we are going to skip it. Moving ahead, the energy of electron in energy band and effective mass we have to calculate. So again, this will be skipped because we are only dealing with questions related to 11th and 12th only. And now coming to 124th. Moving through a liquid of object of mass m experience a resistive drag force proportional to velocity expressed mathematically as F drag is minus bv, where b is constant, the speed of the particle as a function of time when it starts from the rest and falls vertically through the liquid. So here it is mentioned that at t is equal to 0, means when time is 0, velocity is also 0. And from that, using the drag force and buoyancy, we have to find out the relation for the velocity. So inside the liquid, for a ball or object, its mass will be acting downward, and there will be a viscous drag force, that is BV, that will be acting upward. Now there will be also the buoyancy force, but for buoyancy force what we need density of both of the liquid and the solid, and that is not mentioned here. So we assume that there is no buoyancy force. So let us solve only using mass, that gravitational force, and the viscous drag force. Assuming that net downward force is m times a, so we can write that ma is equal to mg minus BV, and we have taken an assumption here that there is no buoyant force. So that's why we can write this formula. Now from this we can write that dV by dt, acceleration can be written as dV by dt, that will be equal to g minus BV by m. And from this I can write that dV divided by g minus BV by m is equal to dt. Now I can further rearrange the terms so that this integral becomes slightly easier. Then I can write dv by bv by m minus of g is equal to negative of dt. I adjusted the negative sign, and with slight more adjustments I can write dv divided by v minus mg by b is equal to minus of P by M dt. Now I'm going to integrate both of these. So from this first, we can say on the left hand side, I will get ln of V minus mg by P. On the right hand side, I will get minus Bt plus C, minus Bt by M plus some constant C. Now, as per given condition that at t is equal to 0, V is equal to 0. So from that, what we will get, I will get that ln of minus mg by P is equal to C. Now, normally this type of expression is invalid because ln of something negative value does not exist, but we are going to use it as it is so that our we can get something matching to this given expression. So let us move ahead and substitute the value of C, and what we will get, ln V minus mg by P is equal to minus Bt by M plus ln of minus mg by P. Now this term we can bring it here in the negative, and this will become ln of V minus mg by P divided by negative of mg by P. And now, and this will be equal to here minus Pt by M. Now I can write it like further. But if I take an antilog, so this will look like something this, that V by minus of mg, and here I will have P, and here I will have negative negative divided, so this will be 1 positive 1, and this will be e raised to power minus Pt by M. Now this can be written as that Bv by mg is equal to 1 minus e raised to power minus Pt by M, and from this I can write it like that velocity is mg by P into 1 minus e raised to power Pt by M. Now if I match it with the given possible answers, let me copy this, copy and paste it here. Oh, sorry, paste it here. So here I have mg by P and 1 minus e raised to power minus Pt by M. So we can say our third option is matching here. So option 3 will be the right answer. Now let us move ahead to the question number 125. So 1 mole of an ideal gas expand isothermally to the 10 times of initial volume. The change in entropy in terms of R, the gas constant, is. So we have to find out change in entropy. So we know that delta S is equal to basically Q by T. And we know that delta Q is equal to delta U plus delta W. Now here we have isothermal process. So delta of U will be equal to 0, and delta of W will be equal to nRT ln V final by V initial. So from this delta Q comes out to be nRT ln of, as volume is changed or expands 10 times, so this will be nRT ln 10. Now n is 1, R is as it is, let's say temperature is also as it is, and we have ln 10. Now we can substitute this value here, that delta S becomes R into ln 10, and from this delta S by R is equal to ln of 10. Now ln of 10 is equal to 2.303, and that is basically option number 2 for us. So option 2 is right here. Moving to the next one. For a relativistic electron of rest mass and node kinetic energy K, the de Broglie wavelength. So this question is basically related to special theory of relativity. special R, and we are going to skip this type of question. So we will skip it. Let us move ahead. So 127. From the fission of a nucleus of uranium-235, 200 mega electron volt energy generated to attain a power of 2 kilowatt, the number of fission per second will be. So what we need 2000 watt energy, and that is basically 2000 joule per second we need. Now one fission produces 200 mega electron volts. So 200 into 10 raised to power 6, and that is an electron volt. So we need to convert it into joule. So 1.6 into 10 raised to power minus 90, and this will give us 3.2 into 10 raised to power minus 11 joule. Now, as mentioned, we need 2000 joule, and one of the fission produces this amount of energy. So let us say n amount of fission produces this 2000 joules. So n into 3.2 into 10 raised to power minus 11 should be equal to 2000. And from this, n is equal to 2000 divided by 3.2 into 10 raised to power minus 11. And when we solve this, we will get 625 into 10 raised to power 11, and that will is 62.5 into 10 raised to power 30 fissions per second. That is the required answer, and that matches with the option 2 here. Now let us move to the 128th. A one-dimensional rod has a linear density that varies with position according to relation lambda x is equal to cx, where c is constant and x is equal to 0 is the left end of the rod. Where do you expect the center of mass of the rod to be? So we have to basically calculate center of mass of the rod. So for that, let us assume this is our rod, and at the left end we have x is equal to 0, and at the right end we have x is equal to capital L, or small l, that is basically the length of the rod. So to calculate the center of mass, what we do, we will assume a small element of length dx at distance x from the given point, that is E. So center of mass here will be xcm, will be integral xdm divided by integral dm. So x will stay as it is. Now dm is the mass of the small element, and that will be mass density into length. Mass density is cx, so cx into dx divided by dm is, that is cx dx. Now integral will be from 0 to l on the both sides. So this will give us cx cube by 3 with limits 0 to l, and on the denominator side we will have cx square by 2 with limits l 0. And c will get cancelled. We will not cancel x cube and x square because we have to substitute limit first here, and that will become l cube by 3 divided by l square by 2, and from that we will get 2 by 3 of L, means center of mass will lie at 2 by 3 of L. Now geometric center will lie at L by 2. So suppose this is geometric center, so this will be at L by 2. So our center of mass is towards the x is equal to L side, or the, we can say this is left hand, this is a right hand. So center of mass will be towards the right hand, and it will be somewhere between geometric center and the right end of the rod. So we can say that option, that to the right of the middle of the rod, that will be the right answer here. Now moving to the next one, 129th. Two tuning forks with natural frequency 340 Hz each move relative to a stationary observer. One fork moves away from the observer while the other moves towards the observer with the same speed. If the observer hears beat of frequency 3 Hz, speed of the tuning fork. So here, as mentioned, that one fork is coming towards, so his frequency will increase, and one is going away, so its frequency will decrease. So from the Doppler effect, we know that F1, that is the, for the tuning fork coming towards the observer, that will be F node, that is 340 here, into with velocity of sound, that is also 340, and observer is at rest, so observer upper side, on upper side there will be no terms, no additional terms, and in the denominator we will have 340 minus velocity because it is coming towards, so it will decrease, or frequency will increase, apparent frequency, and f2 will be 340 into 340 divided by 340 plus 30. Oh, sorry, wait a minute. There is no 30. I somehow assumed it myself. We have to calculate the velocity. So that is, suppose v is the velocity of the these two tuning forks as they are moving with the same velocity. Now their beat frequency is given, that is 3. So beat frequency will be f1 minus f2. So f1 minus f2 is equal to 3. So we will get 3 is equal to, if we take 340 and 340 common from both of these, 340 into 340, and here we will have 1 by 340 minus v minus 340 plus v. And this can be written like that 3 is equal to 340 square, and here we will have 340 square minus v square. Here we will have 340 plus v minus 340 plus v. So 340 gets cancelled, and what we will have? We will have 3 into 340 square minus v square is equal to 340 square into 2 i's of v. Now, if we see the answers, we can see that value of v, which we have to calculate, is either 4, 6, 3, or 1.5. So it means it is very small as compared to 340 square. So we can neglect v square down here because it is very small as compared to 340, and it can be written as 3 into 340 square is equal to 340 square into 2v. These two gets cancelled, and from this 3 is equal to 2v, and velocity comes out to be 1.5, and that is given option number 3. So option 3 will be the right answer. Now moving ahead to the 130. A ray of light travel from an optically denser to rare medium. The critical angle of the two media is C. The maximum possible deviation for the ray will be. So first of all, let's see that how we calculate the angle of deviation. So suppose this is a media that is separating two. This is we can say boundary separating two different mediums, and this is the normal. This is the incoming light, and this is the refracted light. The angle, incoming angle is theta, and refracting angle is phi. Then angle of deviation will be equal to phi minus theta. Now in case of TIR, what will happen? That if I extend this case to TIR, so we know that suppose this is normal, and this is the incident light at critical angle C. So what will happen, that at the limiting case the light will travel along the interface, but this happens rarely. Actually what will happen, that light will be reflected back internally, so light will take path like this, and this and it will obey law of reflection, that if this angle is C, then this angle will also be C. So now in case delta will be, that is the angle of refraction or reflection minus angle of incidence. Now angle of reflection has to be measured from here, because initially that angle was measured from this perpendicular or this normal, so it has to be measured from here. Now this upper angle is 90, and this angle will be 90 minus C. So this total angle will be 90 plus 90 minus C, that is 180 minus C, and this is C. So phi will be 180 minus C minus theta, that is also C. So this will be 180 minus 2C, and that is option 1 here. Moving to the next one. For a sodium Fermi level, energy is 3.1 electron volt, and mean free time for conduction electron is given. Mean free path for such electron is about. So we are going to skip these type of questions as already discussed. Now let us move ahead to 132. A small asteroid is orbiting around the Sun in a circular orbit of radius r0 with speed v0. A rocket is launched from the surface of asteroid with speed v is equal to alpha v naught, where v is the speed relative to the sun. The highest value of alpha for which rocket will remain bound to the solar system, ignoring gravity due to asteroid and effect of the other planets. Now, it is mentioned that rocket should be bound to the sun. So we can say that the rocket will behave like satellite of sun, like on the earth we have moon which is orbiting to the earth, orbiting around the earth, and it is bounded to the earth. So similarly it is mentioned that rocket has to be bounded by the sun, so it will rotate around, it will orbit around the sun, and it will behave like a planet. So basically we can say, or we can assume here, that rocket will behave like a satellite of sun or like a planet for the sun. Now suppose this is our sun, and its mass is ms and its radius is rs. So on the surface of the sun, the escape velocity will be equal to, that will be ve, that will be equal to under root 2g into ms divided by rs. That will be the escape velocity. And if rocket has a velocity less than this escape velocity, then it will stay bounded to the sun. And if its velocity is greater than the escape velocity, then it will leave the, we can say, gravitational attractional force of the sun. Now, as this rocket is behaving like a satellite, and we know for a satellite, total energy of the satellite is equal to minus of g m, where here capital M MSI, it will be capital MS because we are discussing regarding sun. So it will be its mass ms into small m, where small m is the mass of the satellite or the rocket, divided by the twice of the r, where r is the distance between the rocket and the sun. And kinetic energy for the satellite or for the bounded satellite is equal to just modulus of this. So this will be gms small m by 2r. Now this kinetic energy has to be equal to half mv satellite square. So m gets cancelled, and from this, velocity of the satellite, if it is orbiting the sun in a bounded orbit, then that will be equal to under root gms divided by r. Now here nothing is mentioned regarding the distance, that at which distance the satellite is and that at which distance the planet is. So we assume for approximation that rs is nearly comparable to small r. So this expression can be written as gms by rs, and now if we compare both of these terms, then we can write that v escape is equal to root 2 times of the velocity of satellite. Now, as mentioned, that asteroid is launched with the velocity that v is equal to alpha times v naught, where v naught, uh, where here that is v naught, that v naught is the, we can say, velocity of the planet or asteroid. And as that asteroid is also behaving like the, we can say, satellite, so this term, this vs velocity of satellite, will behave like v naught. So vs will be replaced by v naught, and here we have the expression that ve will be equal to root 2 times v naught, and if we compare them, then alpha will be equal to root. So basically what we have done here, if I explain it, we can say briefly, it is mentioned, that suppose this is our sun, there is some asteroid around it, that is asteroid, and we have to launch a rocket from this asteroid such that this rocket stay bounded towards the, bounded with the sun, or it will stay in the gravitational pull of the sun. Now, as mentioned that this distance is not given to us. So what we have assumed that this asteroid is orbiting near the surface of the sun, and this rocket is also orbiting near the surface of the sun. And at the near the surface of the sun, the velocity of this asteroid, that will be equal to under root gms, where ms is the mass of the sun divided by the radius of the sun, or rs. And at the surface of the sun, escape velocity is equal to root 2 times gms by rs. Now we have to find out maximum value of rocket velocity which it can have so that it does not escape. And this is the maximum value which it can have before escaping. So comparing these two, and it is mentioned as alpha v naught. So comparing these two, we can write that alpha will be going to equal to root 2. So with this, let us move to the next one. So 133, for a transistor as an amplifier, choose the correct option regarding resistance of the base emitter and base collector junction. So here we can see that one is base emitter and one is base collector. So it is basically common base transistor configuration. And in common base, what we have normally like this, that this is base, this is emitter in the input, and collector is at the output. So for a transistor to work as an amplifier, its output resistance has to be very high, and input resistance has to be very low. Output resistance is very high. Why? Because it need to drive the circuit. And input resistance is very low, so that it does not causes any extra load. So we can say that output is high and output is CB, or we can say R of BC has to be high. So RBC high, and input, that is RBE, it has to be low. So very low RBE. So option second will be the right answer. Moving to the 134th, system consisting of three identical particle of mass m situated at point given. The inertial coefficient of system matrix from the given y. So basically, we are going to skip this question because it is does not uh, covered in it is not covered in 11th and 12th, or I think not even in the BSc type question syllabus. Moving to the next one, 135. So starting with question number 135 here. A metal ball of specific gravity 4.5 and specific heat given है, placed on a glass slab at ice at 0 degree Celsius. Half of the ball sinks in the ice. Initial temperature of the ball is. So yeah, here what we have to find out, we have to find out initial temperature. And in these type of questions, sometimes we have to ignore some things. So for that, what we have to do, we have to take first, we will take all things into consideration, and then we will solve with it. And if our answer does not match, then we will try to ignore some things. So suppose there is a metal ball. So suppose this is a metal ball, and initially we have ice here. Initially we have ice here in contact with it. Now what happens, as this ball is hot, so it will transfer some of energy to the ice, and now ice will melt in the form of water. So suppose this is water. Now ice has melted and it has become water. Some amount of ice has melted, and now half of the ball is into the ice. So it means that half of the ball is now inside the water and half of the ball is outside the water. So in this diagram, we can say there is exchange of heat. So to solve this type of part, what we can write that amount of heat lost must be equal to amount of heat gained. Heat is lost by the ball and heat is gained by the ice to form the water. And in this diagram, there will be, as ball is inside the water, so there will be a buoyant force acting on the ball that will be in the upward direction, and the mass of the ball will be acting in the downward direction. So let's solve both of these cases. So we can say the amount of heat lost by the ball will be equal to mass of the ball, suppose that is m, into specific heat of the ball, that is 0.1, into change in temperature, that is delta T. And that same amount of heat will be used to melt the ice into water. Now, for that, we need mass of ice into latent heat of fusion, LF. Now here we know latent heat of ice of fusion is already given to us. So we need to get an expression between m ice and m of the ball. So for that, what we will use? We will use buoyancy relation. According to buoyancy relation, what we will have, mg should be equal to the buoyant force. Now mg for ball will be equal to mass of ball, that is m. Okay, let us keep it as it is, mass of ball as it is, into gravity. Now coming to the buoyant force, that buoyant force will be equal to the volume inside the liquid. Now volume inside liquid is half of the ball. As half of the ball is sink inside the liquid or ice, means half of the volume is inside the water. So we can say m, that volume can be written as mass of the ball by density of the ball, and as half of the volume is there, so half of m by rho, into density of, here we will have density of water, but actually only density of ice is given here, I think. Yes, only density of ice is given here, so we will consider that density of ice into gravity. So gravity gets cancelled, and from this relation m also gets cancelled. So from this, what we can write? We can write density of ball divided by density of ice is equal to 1 by 2. But as per the given statement here, what we have here, density of ball is, specific gravity is 4.5 and for ice is 0.9. So means this expression or this method is not going to work here, because we are not getting the same relation. So what we can do, we can go back to the half part, that half of the ball sinks inside the ice. So we can say that mass of the ice will be equal to volume of ice into density of ice. Now volume of ice is equal to half of the volume of the ball, because only half of the ball went inside, so that can be written as half into mass of ball by density of ball into density of ice. Now from this relation, what we can find out, we can write that m ice is equal to m by 2 into density of ice, that is relative density, it has been given to us, that is 0.9, and by density of ball, that is given to us already, that is 4.5. So from this, m ice is equal to basically capital small m by 10. Now small m is the mass of ball. Now we can use this relation here, that m into 0.1 into delta t is equal to m by 10 into lf, that is 80. So from this, m gets cancelled and we will get delta t as 80 degrees Celsius. That change in temperature will be 80. So initial temperature was 80 degrees Celsius, as final temperature is 0, because there still ice is there. So moving to the next one, a charge distribution that is spherically symmetric but not uniform readily produces an electric field of magnitude give is E is equal to k r raised to power 4 directly radially outward from the center of the sphere. Here r is the radial distance from the center and k is constant. The volume density rho of the charge distribution we have to find out. So for this type of expression, what we do, we have to assume that there is some surface charge density. So suppose rho r is the required surface charge density, volume charge density, and it is equal to A into R raised to power n, where we have to calculate A and n. We have to, both these we have to calculate. So if we consider a small element of volume dV, and that dV will be equal to 4 pi r square dr, because it is a spherical element. So then dq, the charge in that small have a charge inscribed in that small volume, that will be rho r into dV, and that will be equal to a r n 4 pi r square dr, and that will give us 4 pi a r raised to power n plus 2 dr. Now from the Gauss law, what we can write, that integral E dot ds is equal to q enclosed by epsilon law. Now q enclosed can be written as that E dot ds is equal to 1 by epsilon naught. Q enclosed can be written as integral rho dv. So let's find out electric field up to distance r. So here we will have integral 0 to r. So this will give us E dot 4 pi r square is equal to 1 by epsilon naught integral of this term up to upper limit r and lower limit 0. So 4 pi a is constant, and integration will give us r n plus 3 divided by n plus 3. Now from this we can cancel 4 pi, and r square is can also be adjusted. So from this we will get E is equal to a raised to power r plus 1, a into r raised to power n plus 1 divided by epsilon node into n plus 3. And this should be equal to the given electric field, and the given electric field in the expression is k into r raised to power 4. So this should be equal to k into r raised to power 4. So comparing value of r raised to power, here r has power n plus 1 and here r has power 4. So from that n plus 1 is equal to 4. So n is basically 3. So this electric field relation becomes A r cube divided by 3 plus 3 6 epsilon naught is equal to k into r raised to power 4. Oh sorry, this will be 4. Now R4 gets cancelled, and from this we can get a value of A, that A is equal to 6 times K times epsilon. Now we can substitute here all the values, that A is 6K epsilon naught and N is 3, so 3 R raised to power 3. Now let us compare with the given answer, and we have match at option second, 6K epsilon R cube. That is the required match here. Let us move to the next one. The angular momentum of an electron with L given by this value, and how many different value Lz are possible. So this is related to quantum mechanics, and we are going to skip this one. So let's move to the next one, 138. An object of mass m accelerates uniformly from the rest to velocity v naught in time t naught. What is the instantaneous power delivered to the body when its velocity is v naught by 2? So we have a relation for power, that power is equal to force times velocity. Here it is mentioned that body accelerates from rest up to velocity v naught in time t naught. So basically acceleration, that will be equal to delta v by delta t, and that will be equal to v naught by t. Now as mentioned here, that we have to find out power when velocity is v naught by 2. So for that we need force, and force is equal to mass time acceleration. Acceleration is v naught by 2, so this becomes mv naught by t. And now power becomes mv naught by t into v naught by 2, and that is mv naught square by 2t. So that is option 3 for us. Now let us move ahead to the next one, 139. An ideal gas follows a process described by PV square is equal to C, where C is constant. Then from P1 V1 T1 and P2 V2 T2, then we have to find that which of the relation holds true here. So as mentioned, that PV square is constant, and this is for ideal gas. For ideal gas we also know that PV is equal to nRT. So from this what we can do, we can from here PV square is equal to C. Then let's find out value for P, that P is equal to C by V square. Substitute it here, that C by V square into V is equal to nRT. Now N is constant for gas and R is also constant for gas. So and C is also constant here. So from this we can write that 1 by V is proportional to T. So if volume is going to increase, temperature is going to decrease. So temperature will behave inversely as per the volume, and here that is the second relation, that V2 is greater than V1, then T2 will be smaller than T1. So option second is the right answer here. Let us move to the next one. Question number 140. At low temperatures, d by temperature of two isomorphic ionic solids AB and XY are 300 Kelvin, 250 Kelvin respectively. The lattice heat capacity of AB is given. Then the lattice heat capacity of XY is 5K is. So this is related to solid state physics. And as we already discussed that we are going to skip these type of questions. Moving to 141. A rectangular plate has length and width. The maximum percentage error in measurement of area. So we know that area is equal to length times breadth or width. So percentage error, that will be delta A by A into 100 will be equal to delta L by L into 100 plus delta W by W into 100. So delta L will be here 0.04 divided by 4 into 100, plus for which it will be 0.02 divided by 2 into 100. And when solve this, we will get 2%, one from this and one from this. So total 2% will be there, and that is option 4 for us. Now let us move ahead to 142. In a certain system of unit, if viscosity eta, surface tension S, and volumetric flow Q are used as fundamental quantities, then the dimension of time in that system. So this type of question, we know in the dimension analysis that time can be written as neta raised to power A, surface tension raised to power P, and volumetric flow Q raised to power C. Now for neta we have relation that F is equal to neta A dV by dx. For surface tension we know that force is surface tension per unit length, and volumetric flow Q is volume per unit time. So from these we can find out dimensions. So T will be equal to, neta dimension will be m1 L minus 1 T minus 1 raised to power A. Surface tension will be m T mt minus 2 mt minus 2 raised to power P, and volumetric flow will be L cube T minus 1 raised to power C. So when we collect powers, we will get m is equal to m raised to power A plus B, L raised to power minus A plus 3C, and T raised to power minus A minus 2B minus C. And here we have m T raised to power 1. So A plus B will be equal to 0. So from that A is equal to minus B, or let us write B is equal to minus A. From here we will get minus A plus 3C is equal to 0. So A is equal to 3C. And from here we will get minus A minus 2B minus C is equal to 1. So minus of A, that will be equal to minus 3C, and minus, here we will have 2B, and twice of B, as B, here we can substitute like this, B is equal to A and A is equal to minus 3C, so this is minus 3C. So minus minus plus 3C minus plus 6C, and minus C is equal to 1. So from this we will get C is equal to half. If C is equal to half, A is equal to 3 by 2 and B is equal to minus 3 by 2. So basically our relation will be that T proportional to neta raised to power 3 by 2, S raised to power minus 3 by 2, and further we have Q raised to power half. So that will be that P is proportional to neta cube divided by S cube into Q raised to power half. And that is none of these. None of these. Because here we have power 1 by 3. So none of the given answer is right here. Now let us move ahead to the next one, 143. An electromagnetic wave has frequency V node, nu node, wavelength lambda node passes from the free space of a non-magnetic medium with permittivity epsilon. If delta V and delta lambda are the respectively increments in the frequency of the wavelength in medium and c is the velocity of light, then we have to calculate delta V and delta lambda. So basically from the electromagnetic theory, we know that when light changes its medium, then there is no change in frequency. Means delta V has to be zero. And when light changes medium, then lambda changes. And if lambda changes, then we can say delta lambda will not be equal to zero. And from this conclusion, from these two hints, we can find out easily that option third and first are directly ignored using this one, and option fourth will also be ignored as delta lambda cannot be zero, so only option 2 will be the right answer. And if we want to solve expression for lambda, then what we can use, we can use electromagnetic theory, that according to electromagnetic theory we have velocity will be equal to under root 1 by mu naught into epsilon, and speed of light is equal to, that is mu naught epsilon naught. Now we know that when light changes medium, then its lambda dash or the new wavelength becomes lambda divided by mu, where mu is the refractive index. So let us divide these two terms. If we divide here, that one we will get V by C is equal to epsilon naught by epsilon. Now between the wavelength, frequency and speed we have a relation that V will be equal to frequency, as frequency does not changes, into lambda dash, and C will be equal to frequency into lambda. So from here, if we divide both of these, V by C, then it will be equal to lambda dash by lambda. Now equating both of these, we will get lambda dash by lambda is equal to epsilon naught by epsilon. Now we have to find out uh, delta lambda. So delta lambda, how we can calculate? We can calculate it divided by subtracting 1 from both sides. So from this we will get lambda dash minus lambda by lambda is equal to, we can write epsilon naught minus under root epsilon by under root epsilon. Now this upper term can be written as delta lambda. So delta lambda is equal to under root epsilon naught minus under root epsilon by under root epsilon into lambda. Now from this relation, lambda can be written as C by F, where F is the frequency, and in the expression they have taken expression frequency as V naught. So lambda can be written as C by V naught. If we substitute it here, then what we will get? We will get delta lambda is equal to, and if we can also write it like this, epsilon naught by epsilon minus 1 into C by V naught. So we can see that our expression somewhat matches with the given answer. So that's how we can ensure that option 2 will be the right answer here. Now moving ahead to question number 144. A stiff spring obeys force law given by this relation. Work required to stretch the spring from the relaxed state from x0 to xl is W node. In terms of W node, work required to extend the spring from stretch length L2 to the 2L. So we know that work done is equal to integral of negative f dot, oh sorry, not negative, work done is equal to integral f dot dx. So here w will be integral of minus kx cube dx. So from up to 0 to L it is W naught. So if we integrate it, then W naught will be 0 to L minus kx cube dx, and this will actually here we will get positive sign. Why? Because this is f dot dx. Normally when we stretch, then the force and the displacement are in the opposite directions, because restoring force is towards the center and displacement is happening up in the opposite direction. So there we have 180-degree angle, and f dot dx will be equal to f dx cos 180. So that's why we will get positive sign, and from that we can calculate that w node will be equal to k l raised to power 4 by 4. Now we have to calculate work done from L2 to L. So let's say that is W dash will be equal to L2 to L kx cube dx, and that will give us, okay, kx 4 divided by 4 with limits to L and L. And when we solve this, we will get 15 KL4 by 4, and that KL by 4 is W node, so that is 15 times W node, and it is option number 3. Let us move to 145. So the period of a particle executing SHM is 8 seconds at t is equal to 0 is at mean position. The ratio of distance covered by the particle in first and second will be. So for the particle SHM, we can write equation that x will be equal to a sine omega t, and here time period is 8 seconds, means we have omega will be equal to 2 pi by t, that will be equal to 2 pi by 8 or pi by 4. So this will become a sine of pi t divided by 4. Now x1 is the displacement in the first second, so x1 will be equal to a sine pi by 4, and that is equal to a by root 2. Now x2 is the displacement from the mean to the up to time is equal to 2 seconds. So that will be a sine pi by 4 into 2, and that will be equal to a. Now we have to calculate displacement only in the second, not up to second, only in the second, and that will be equal to, let's say, x2 dash, and that will be equal to the displacement up to 2 seconds minus displacement up to 1 second, and this will give us a into 1 minus 1 by root. Now we can take ratio that displacement of first second divided by second, so that will be equal to x1 by x2 dash, and that will give us a by root 2 divided by a into, I think, 1 minus 1 by root. This will, a gets cancelled, we will get 1 by root 2, here root 2 minus 1 by root 2, so root 2 get cancelled, and this is 1 by under root 2 minus 1. That is option 3. Let us move ahead. The intensity of sound wave A is 100 times that of B relative to wave B. The sound level of A is. So we know for the decibel, we have relation that decibel is equal to 10 log 10 of IA by I know. Now this is for some sound A. Similarly for B, dB will be equal to 10 log 10 IB by I node. And from this, if we divide both of these, oh sorry, we have to find out relative intensity. So for relative intensity, we can directly write that dB will be equal to 10 log of 10 IA divided by IB. That we can directly write, and this will become 10 log 10, and relative intensity is 100, so here we will have 100, that will be 10 into 2, that will be 12. our relative intensity will be 20 decibel. Now let us move to next one, 147. A circular disk of radius r and thickness r by 6 has a moment of inertia I about axis passing through the center and perpendicular to the plane. It is melted and recasted into solid sphere. The moment of inertia of sphere about its diametrical axis. So here, moment of inertia of disk it, that will be equal to half mr square, and as it is recasted and melted, so volume will be constant here. If volume is constant, then mean volume of the disk is equal to volume of sphere. Now volume of disk will be pi r square, that is the area, into width, that is r by 6, into volume of sphere, that will be 4 by 3 pi into small r, assuming small r is the radius of sphere q. From this we can find out that small r is equal to capital R by 2. Now moment of inertia of sphere, as it is a solid sphere, so that will be 2 by 5 into m small r square, and it does not matter about which axis you are measuring. If it is passing through the center, it will always be same. So that will be 2 by 5 into mass. Mass will stay the same as we are using the same mold, into r by 2 square. This is 1 by 10 m r square, and for the disk we had half mr square, and for the sphere we have 1 by 10 mr square. So this is basically moment of inertia of disk divided by 5. That is second option for us. Moving to the next one, 148. A certain vector in xy plane has an x component 4 meter and y component 10 meter. So we can say that vector is basically, let us say that is capital A, that is 4i plus 10j. It is then rotated in xy plane so that x component is doubled, the new y component is. Now this vector is rotated. Now what happens with rotation? When vector is rotated, its magnitude stays same. Magnitude stays same. So after rotation, suppose it becomes vector B. Initially it was A, after rotation it becomes B, and we know due to rotation, magnitude of A will be equal to magnitude of B. Now magnitude of A is under root 16 plus 100. Now for B, now coming to vector B, its x components become doubled. So initially x component was 4, now x component becomes 8, and y component we have to calculate. So let us say yj. So its magnitude will be 64 plus y square. Now if we compare, we will get 116 is equal to 64 plus y square, and from this y square comes out to be 52. That is, we can say something around 7, and that is second option for us, 7.2. Moving to next one, electron of energy 64 electron volt is incident on a potential barrier of height 100 electron volt with 0.1 millimeter. So this question is basically quantum mechanics related, so we are going to skip it. Now let's come to the last question. Specific heat of aluminium is more than twice of copper. So let us assume that specific heat of aluminium is at least twice the specific heat of copper. Identical masses of copper and aluminium, both are 20 degrees Celsius, are dropped in a calorimeter containing water at 40 degrees Celsius when thermal equilibrium is reached. So here is it mentioned that we have reached thermal equilibrium. So if thermal equilibrium is reached in both cases, then we can say delta T will be the same. And for Q, we have mentioned that Q is equal to mc delta T. Now here we have identical masses, means m is same, delta T is same, so Q is basically proportional to C. And C for aluminium is greater, so we can say aluminium will absorb more heat. So that is option third here, that aluminium has absorbed more energy than the copper. So with this video ends here, and our HTET series is also ends with this one. Hopefully you have enjoyed the whole video and this whole series. If you find these videos useful, then do press the like button, share them, and subscribe to our channel. Also, if you like to support us, then you can scan these QR codes in front of your screen, and you can check out our other videos also. I will be keep on bringing these type of videos on regular basis. With this, again, thanks for watching, and we will meet in next video.